Welcome to The Explainer. Today, we're tackling something absolutely massive. We're looking at the biggest footprint out there, greenhouse gas emissions, and energy resource planning. Specifically, we're going to explore the strategies for mitigating carbon outputs from fossil fuel combustion. We'll be looking at the electric utilities and power generators industry through the lens of the SASB standards. Unpacking exactly how these frameworks hold utilities accountable for their sheer environmental impact. It's exactly where long-term energy planning meets hard, undeniable financial data. Let's get into it. Okay, let's dive into this. Here is our roadmap for today. To manage emissions, we first have to understand exactly how they're measured. So we'll cover 1. The biggest carbon footprint. 2. Measuring Scope 1 emissions. 3. Accounting for power deliveries. 4. Navigating the regulatory landscape. And 5. Planning for a greener grid. Section 1. The biggest carbon footprint. To really grasp this, we have to recognize the sheer scale of the challenge here. Electricity generation is the single largest source of greenhouse gas emissions worldwide, period. Now, the transmission lines you drive past every day, they produce pretty negligible emissions themselves. But the actual combustion of fossil fuels at the power plants, that makes this industry literally the critical battleground for global climate change. And you have to understand, this isn't just an environmental issue, right? It is a massive financial one. As environmental regulations around the world become increasingly stringent, utilities face severe operational and financial risks. Think about it. If a company fails to proactively reduce its footprint, or say they miscalculate the capital expenditures needed to upgrade their facilities, they could be hit with massive asset write-downs. They might face exorbitant costs just to buy carbon credits, or suddenly find they need to drop millions on unexpected compliance tech. It's a really high-stakes balancing act for sure. All right, moving on to Section 2, measuring Scope 1 emissions. So, let's zoom in a bit. What exactly are Scope 1 emissions? Well, under the GHG protocol, these represent your direct on-site outputs. We're talking stationary sources like giant facility boilers and mobile sources like a utilities transportation fleet. It's kind of like tracking every single penny in a household budget before you can even start thinking about cutting costs. You just can't actively manage your carbon liabilities until you have an exact, comprehensive corporate ledger of these direct emissions. Now, the SASB standard specifically requires tracking 7 greenhouse gases, the ones covered under the Kyoto Protocol. You've got carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. Because these are the primary byproducts of fossil fuel combustion, they absolutely demand rigorous tracking. But here's the kicker, right? These gases are completely invisible, and they trap heat in the atmosphere at wildly different rates. So how do you even compare them? Well, the accounting standard handles this by anchoring them all into a single standardized unit of weight, metric tons of CO2 equivalent, or CO2e. They do this by applying a 100-year global warming potential value to each gas, relying on data from the Intergovernmental Panel on Climate Change. Basically, this ensures that a ton of methane and a ton of carbon dioxide can be weighed accurately on the exact same environmental scale. Section 3, accounting for power deliveries. Now, accounting for emissions goes way beyond just what a utility generates at the plant. It actually requires tracking the product that reaches the consumer. The methodology works like this. First, you calculate gross global emissions by summing the outputs from your own facilities. Then, you add emissions from any power you purchased from third parties. Next, you subtract power resold to the wholesale market. And finally, and this is absolutely crucial, you include emissions from power loss during transmission and distribution. It's a complete end-to-end life cycle calculation of the energy's journey. Which brings us to Section 4, navigating the regulatory landscape. Now, what's really interesting about this slide is how utilities must navigate 2 very distinct regulatory frameworks. On one side, you have emissions limiting regulations. These have teeth. They set hard caps, mandate carbon taxes, or enforce permits to directly limit and cost out emissions. Conversely, emissions reporting regulations are completely different. They merely demand public disclosure of your GHG data without actually imposing hard limits or financial penalties on the emissions themselves. Just to give you an idea, some high-profile examples of those limiting programs include the California Cap-and-Trade System, the massive European Union Emissions Trading Scheme, and the Quebec Cap-and-Trade Program. If you're operating in these jurisdictions, you have to master these highly specific permit-based mechanisms, or you're going to face some heavy financial penalties. And finally, Section 5, planning for a greener grid. So looking back at historical reporting is one thing, but how are utilities planning for tomorrow? When a utility shares its emission reduction targets, they have to follow a very strict blueprint. First, they must set a base year. That's your absolute starting point. Next, they declare the target type. Basically, are they committing to a raw absolute reduction in total tons or an intensity-based reduction, like per megawatt hour? Then they must precisely define the scope. What percentage of their total emissions does this target actually cover? And lastly, they lay out the mechanism for achievement, detailing exactly how they will practically execute this plan.
Let's connect the dots here, because these strategic moves directly impact the bottom line. Investing in cleaner technologies, that mitigates unanticipated compliance costs down the road. Developing optional green power markets allows customers to voluntarily fund renewable expansion. And proactively changing operational processes prevents sudden, incredibly costly asset write-downs. Shrinking the footprint actively protects the business from financial disaster. And this brilliantly illustrates how all of these different metrics consolidate into a single, standardized framework, specifically the SASB IFU 1108 table for greenhouse gas emissions and energy resource planning. This brings together the quantitative data for Scope 1 and power deliveries, along with the qualitative analysis required for long-term reduction strategies. The whole shebang gives an investor-grade view of climate risk and the company's response to it.
So what does this all mean? Well, thanks to these rigorous accounting standards, we now know exactly how to measure, categorize, and regulate the massive footprint of electric utilities. The baseline is firmly established, the data is clear, but that ultimate tension remains, right? Balancing our constant demand for reliable power with the urgent reality of climate change, how fast can the industry actually shrink it? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.